Have you ever looked up at the night sky and wondered about the countless twinkling stars? Each of those stars is like our sun, a giant ball of burning gas. And around many of them, planets orbit just like our Earth revolves around the sun. Our Earth, a tiny speck in this vast universe, has a fascinating story to tell, a story of its birth and evolution over billions of years. Imagine a time when there was nothing, not even space or time. Then, about 13.8 billion years ago, a massive explosion, which scientists call the Big Bang, occurred. This explosion marked the beginning of the universe. It's hard to fathom the scale of the Big Bang and the sheer amount of energy it unleashed. It's an event so monumental that it continues to shape the universe even today. The Big Bang wasn't an explosion in the conventional sense. It was more like an expansion, an incredibly rapid stretching of space itself. In the first fraction of a second, the universe was unimaginably hot and dense. But as it expanded, it cooled down and became less dense. As the universe cooled, tiny particles started to form from the energy. These particles then combined to form atoms, the basic building blocks of matter. Over millions of years, gravity pulled these atoms together, forming vast clouds of gas and dust. These clouds, called nebulae, became the birthplaces of stars and planets. About 4.6 billion years ago, in a corner of our galaxy, the Milky Way, a giant cloud of gas and dust started to collapse under its own gravity. As this cloud collapsed, it spun faster and faster like a spinning top. The center of the cloud became incredibly hot and dense. This hot, dense core eventually ignited, releasing a tremendous amount of energy. Our sun was born. The sun, a giant ball of burning hydrogen, became the anchor of our solar system. Its immense gravity would hold together everything that was to come. While the sun blazed at the center of the newly formed solar system, the remaining dust and gas continued to swirl around it. Over millions of years, these particles collided and stuck together, forming larger and larger clumps. This process is called accretion. These clumps, called planetesimals, continued to grow, pulling in more and more material with their increasing gravity. Eventually, these planetesimals became large enough to form planets, including our own Earth. Imagine the early solar system as a chaotic dance floor, with these planetesimals bumping into each other, some growing larger, others breaking apart. Section 5. Gravity's pull shaping our Earth. The early Earth was a hot, molten ball of rock, constantly bombarded by asteroids and comets. These collisions generated immense heat, keeping the planet in a molten state. Over time, as the bombardment slowed down, the Earth's surface began to cool and solidify, forming the first crust. Gravity played a crucial role in shaping our planet. It pulled the denser materials like iron and nickel towards the center, forming the Earth's core. The lighter materials like silicon and oxygen remained closer to the surface, forming the Earth's mantle and crust. Section 6. Oceans and atmosphere. The essence of life. Volcanic eruptions released gases from the Earth's interior, forming the early atmosphere. This early atmosphere was very different from the air we breathe today. It was thick with carbon dioxide, nitrogen, and water vapor, but it lacked oxygen. As the Earth cooled further, the water vapor in the atmosphere condensed and fell as rain, forming the first oceans. These early oceans were acidic and hot, but they provided the essential ingredient for life to emerge. Section 7. The Goldilocks Zone, Earth's perfect position. Earth's position in the solar system is crucial for life as we know it. We are located in what scientists call the Goldilocks Zone, not too hot, not too cold, but just right for liquid water to exist on the surface. If Earth were closer to the sun, like Venus, it would be too hot, and the oceans would boil away. If we were farther away, like Mars, it would be too cold, and the water would freeze. Our perfect distance from the sun allows for the existence of liquid water, a key ingredient for life. Section 8. A continuous evolution, Earth's ever-changing face. The Earth's story doesn't end there. Our planet is a dynamic, ever-changing system. The continents have drifted across the surface, breaking apart and colliding to form new landmasses. Volcanoes have erupted, spewing lava and ash that have shaped mountains and valleys. The oceans have risen and fallen, carving coastlines and shaping the land, and life itself has played a significant role. influencing the composition of the atmosphere and shaping the planet's surface. Section 9. A blue planet teeming with life, a precious home. From a swirling cloud of dust and gas, Earth has evolved into a vibrant planet teeming with life. Our journey from a hot, molten ball of rock to a life-sustaining world is a testament to the incredible forces of the universe. As we look up at the night sky, let us remember that we are part of something much larger than ourselves. We are children of the stars, born from the same cosmic material that makes up everything around us. And it's our responsibility to cherish and protect this pale blue dot, our only home in the vastness of space.